Okay, this video is going to go over how to factor complex trinomials. A complex trinomial is when you have your trinomial, your x squareds, your x's, and your c's, but a is not 1. So a is the coefficient of x squared. So maybe you have 3x squared, negative 2x squared. A is not 1. It's a little bit more complex, hence the name, than simple trinomials. But let's go through and show you a couple ways to do it. First, good idea, pause the video. The warm-up is all things that we have already done. So if you want to pause the video, go through those 5 warm-up questions and then resume the video, see if you got those right. Okay, there you go. So there's those 5 answers. You can pause the video, look through those solutions if you want. I'm going to focus this video on factoring complex trinomials. So again, factoring trinomials like a through f, where you can see your a values, the coefficients of x, are not 1. There's 2 ways to do this. One way is called tabletop. Right? So one option is tabletop. Another option is decomposition. Okay. There's a couple other methods, but these are the 2 that are kind of used most frequently. So what I'm going to do is I'm going to solve each of these below using both of those. It says tabletop. That's my preference. But depending on how you learn, you might have the preference of decomposition. Okay. So for tabletop, I'm just going to write this question A over here. 2x squared plus 11x plus 5. And ultimately I want to factor it into two brackets. What we do is you kind of set up a table. It kind of looks like a coffee table there, or with the legs or those 2 lines. What I want to do is to put numbers here and here that will multiply to 2x squareds. And then I want to put numbers here that multiply to that positive 5. Color code this. And how I know I'm right is if I cross multiply. So I take that top blue number and multiply it with the bottom red number, and then cross multiply, right? So the bottom blue and the red. If when I cross multiply, I can get to 11 x's from those 2 products, then I've got this factored. So let's go through and see how this could look. So what can multiply to 2x squareds? Well, that's got to be 2x and x. 2 is a prime number, it's got to be 2 and 1. What can multiply to 5? Well, 5 times 1. How I know I'm right is I look to the cross multiplication. So if I look on this cross sum, the cross line, 2x times 1 gives me 2 x's. Oops, why am I on a highlighter? Gives me 2 x's. When I cross multiply the other sides, there I get 5 x's. 2x and 5x. I cannot work with 2x and 5x to make 11 x's. So what I want to do, or what I'll need to do, is try the 1 and the 5 in different spots. If I put the 1 up top and the 5 down below. Now let's see what I get for those crosses. This line gives me 10 x's. This line gives me 1x. Oops, 1x. 10x and 1x give me 11x. There we go. So that table has been used to set up my thinking. In order to factor this now, your brackets actually go across. So that there is one bracket. 2x plus 1. My second bracket is down below, x plus 5. So that there is called tabletop. There's another method, and I'm going to do the exact same question using the method of decomposition. The method of decomposition is you look to your first and your last numbers and you multiply them. So 2 and 5 gives me 10 x's. I want it, sorry, not 10 x's, just 10. Okay, so I'm just looking at those coefficients. So I want something, I want to find two numbers that multiply to 10, right? Multiply to the product of A and C. Okay, so you multiply A and C, and you're trying to think of two numbers that multiply to that. Okay, well, what multiplies to 10? 1 and 10, or 2 and 5. The option we're going to use will have to add to the middle. So I want things that add to 11. Which of those sets adds to 11? The 1 and the 10. So this is what we do if you use the decomposition method. You take that 11x and you break it down into those two terms. You break it down into 1x and 10x. Now your next step for decomposition is you factor by groups. So you try to common factor each of those. In that first group, 2x squared plus 1x, I can common factor out an x. And what I'm left with there is 2x plus 1. In my second group, 10x plus 5, I can common factor out a 5. And here I'm left with 2x plus 1. This bottom row here is just like this example 2, where we had the common factor of the bracket. We've seen this a few times now. I've got a common factor in these two terms. Both of those terms have a factor of 2x plus 1. If you common factor out a 2x plus 1 from each term, in that first term here, you factor out that bracket, you're left with an x. In the second term, you're left with a 5. Notice you get the same answer both ways. So it's up to you to decide which option you like better. Let's do question B. Actually, I'll just erase all of that. Okay, so let's do B. Question B is 3x squared plus 8x plus 4. First thing I'm going to do is the tabletop option. So with tabletop, I want to put terms below the 3x squared that multiply to 3x squared. 3x times x. Nice and easy, 3 is a prime number. Under the 4, I want to put numbers that multiply to a 4. So I could do 4 and 1. To check if you're right, you need to check your cross sums. So that there, 3x times 1, that gives me 3x. This gives me 4x's. 3x and 4x does not give me the 8x term in the middle. I am looking to cross multiply and to add those two lines to get to 8x's. So 4 and 1 didn't work. I'm going to erase them and try other spots. Now when I cross multiply, that there gives me 12x. That there gives me 1x. 12x and 1x cannot get me to 8, so that's not right. So 1 and 4 didn't work. It's a good idea when you have a number that's not prime, so a number that has a couple sets of factors, to make a list. So 4 could be 1 and 1 or 2 and 2. I just tried those in both spots and they didn't work. So I'll try my next set, 2 and 2. Oops. 3x times 2 is 6x's. X times 2 is 2x's. Ooh, 6x and 2x can make that 8. So that is going to be my factored form. I've done all of my thinking now. Now I need to go and just write them in my brackets. This isn't like that tabletop. This stuff here is just thinking. It's not my answer. One bracket from the top, one bracket from the bottom. There you go. Let's do the same question using decomposition. So decomposition, you've got 3x squared plus 8x plus 4. In this one, what you want to do is you want to find the product of a and c. So a and c. 3 times 4 is 12. I want to find numbers that multiply to 12. So it could be 1 and 12, 2 and 6, or 3 and 4. But I want them to add to the middle term. Which of those sets adds to 8? 2 and 6. So I'm going to decompose this. That 8x, I'm going to change into a plus 2x and a plus 6x. And now, once I do that, I common factor my sets. So 3x and 2x, the only common factor is an x. I would be left with 3x plus 2. My second set, 6x plus 4, I can common factor out a 2, and I'm left with 3x plus 2. Notice again, I have two terms. Each term has the same bracket, 3x plus 2, so that's a common factor. And then what I'd be left with is x plus 2. So the same answer in two different ways. Let's do C. 3x squared minus 5x plus 2. Tabletop. What can multiply to 3x squared? 3x times x. What can multiply to 2? Well, 2 is a prime number, so you only have the option of 1 and 2. If I do it this way, quickly do those cross sums, that gives me 3x's. This one gives me 2x's. Can I work with 3x and 2x to get negative 5x's? I can, if they are both negative. So negative 2 and negative 1. 3x times negative 1 makes the negative 3x. X times negative 2 gives the negative 2x's. And, most importantly, negative 2 times negative 1 still gives me that plus 2 at the end. So there we go. We have factored this one. 3x minus 2, x minus 1. Same question for decomposition. I want to find things that multiply to 3 times 2. So I want them to multiply to 6, and then I want them to add to negative 5. So what can multiply to 6? 1 and 6, or 2 and 3? careful here, because you might think 1 minus 6 is a negative 5, but 1 times negative 6 does not multiply to a positive 6. So that doesn't work. This option works if I have a negative 2 and a negative 3. Negative 2 times negative 3 is a positive 6. Negative 2 take away 3 is a negative 5. So I'm going to decompose that minus 5x's into a minus 2x and a minus 3x. Now I'm going to common factor. What can I common factor out of there? An x. And I'm left with 3x minus 2. What can I common factor out of that? Just a 1. But I'm actually going to factor out a negative 1 because that's a negative. And I'd be left with 3x minus 2. Again, I have the same two brackets. So my common factor would be 3x minus 2 times x minus 1. So there's 3 examples that are done using both tabletop and decomposition. Pros and cons to each. Just kind of depends what your preference is. I'm going to do a second video. This one's getting kind of long, so I'll do a second video for those 5.